Hello, my name is Ben Coleman. I'm a cloud solution architect working at Microsoft. Today I want to show you a step-by-step demonstration and walkthrough of how to do continuous integration and continuous deployment and DevOps in Azure using an open source deployment stack and an open source platform services running in Azure and running in the cloud. What I'm going to step through today looks a little like this. This is both a kind of overview of what we're going to run through, but also the pipeline and life cycle of my application. We're going to develop a Node.js, a Node.js Express application, a little web application, and we're going to then package that as a Docker image, so we can deploy it as running as a container. So we do this through Dockerizing our application, so to speak. And then from there, our application source code and Docker build information gets put into a Git repository. The Git repository then kind of forms the kind of backbone of a continuous integration process. From the Git repository, we then build our, using continuous integration automation, build our Docker image into a Azure Container Registry. And then from our images that are stored in there, get deployed into Azure Web Applications, which are platform services using a continuous delivery pipeline. It's probably worth mentioning, this is all available over on GitHub. So we have a link to that here, aka ms/DevOps lab. I think that flashed up a little too quick. Yeah, this URL here, I'll put a link in the video and in the description. But this will bring you over to this repository here, which contains obviously some of the source code we're going to go through today, some of the information, but more importantly, really, is this long step-by-step guide, which anyone can follow. Very, very few prereqs, and doesn't assume any knowledge of Azure or the other tooling here. So this really is a kind of beginner's guide who wants to follow what I'm doing today on their own. So coming back to what we're doing today. This is a kind of good overview of our target architecture and what we're going to be standing up. Over on the left-hand side, we have kind of the local environment, what the developer's working on. So we've got the developer down there. Oddly enough, looks a little bit like me. And he's got his workstation there where he's going to be building his local application, in this case, the Node.js Express app. From there, he's going to integrate his source code into the Git repository, which is stored online in the cloud in Visual Studio Team Services. Visual Studio Team Services is kind of the heart and the backbone of what we're doing today, because this will drive our continuous integration process and our continuous delivery process. So the continuous delivery is going to target Azure and stand up a range of different environments for us. We're going to use Azure Container Registry, which is hosted inside Azure to store our images. And then from there, Visual Studio Team Services is going to use infrastructure as code and templating to build multiple environments to stand our application up. So here, just for example, dev, test, staging environments. Each of those environments will host an Azure Linux web application, which uses Docker containers, which can then run our Node.js containerized application and stand up our application. So let's make a start. Over here, I'm going to start from scratch. I don't have anything ready prepared. I'm going to build my application from first principles. So Node.js and Express comes with a generator. So I'm going to run this generator command and tell it I want to create an application based on the templating system called Pug. Yeah, it's not the best name, but it's what they decided. It used to be called Jade, which was a much better name, but it's now called Pug. And I give a directory or kind of name of my application. I can't think of anything better today, so let's just call it my app. Great, that's quickly generated. Doesn't take very long at all. Basically a templated version of a Node.js application. So let's go in there. And what I'm going to launch is Visual Studio Code. Let's just make this full screen. It's a little bit smaller. So Visual Studio Code, really great multi-platform code editor, lightweight IDE. It's multi-platform, runs on Linux, runs on Windows, runs on OS X. It's nothing like its bigger brother, Visual Studio. As you saw then, it started up in a couple of seconds, and it's just a really, really nice development environment for kind of open source projects just like Node. So the first thing we need to do with any Node application is run npm install, and this will pull down the various modules and other elements that our application is dependent upon. While we're doing that, we can have a quick look at our application that it's created for us, the generator. So it's created a very basic application with an index page and some style sheets. And we'll go in a moment and edit these and improve the application a little bit. So that's run through. It's probably worth mentioning here. So within Visual Studio Code, I have a built-in terminal environment, so I can have multiple terminals down here, and I can work without having to go back to command prompts. It just makes it a really nice environment to work within. You never need to leave, so to speak. So I run npm start. It will create an instance running locally of my application, running on localhost. So I can come over here, come back to my browser, go to localhost 3000, and we get our kind of generated application. It's pretty basic. It's super bare bones. Nice minimal clean design, but I think we could do a little better, and we could probably do some work to improve this and make it look a little bit better. So let's quickly do that. I've got some snippets of code I'm going to bring in here to save me writing everything from scratch. I'm just going to update some of the views here. I'm also going to update the JavaScript behind that. And I'm not going to update the style sheet, so it looks a little nicer. At least I think so. Let's save all our files. We'll need to restart the Node application. So let's quickly do that. One of the downsides of Node. And come back here, refresh our browser. And there we go. I think you'd agree this looks a little better, depending on your tastes. But yeah, the key thing here is that we're pulling out a little bit of system information. So this will make a difference, obviously, when we're deploying it over in Azure and running inside a container. Hopefully this will reflect that. And we're also able to detect whether we're running inside a Docker container. So at the moment, I'm just running it as a process on my machine. So the application is telling us that. Okay, what do we need to do next? Well, that's my application. It's kind of good enough, I think, to run through our continuous integration and deployment test stage. I don't want to spend any more time on actually writing the application today. Obviously, this is very simple, but the principles still kind of apply. So what I'm going to do now is Dockerize the application, and we can do that with the help of extensions that are provided. And there's an extension for Docker provided by Microsoft here, which provides a lot of capability to developers to be able to integrate their applications into Docker through Visual Studio Code. So to do that, I can bring up a little helper prompt here, Control-Shift-P. If I type Docker, I get a list of different Docker capabilities I can do. I can build images, push them, and manage Docker straight from Visual Studio Code. But then I can also choose Add Docker files to my project. I can choose what type of project it is. In this case, we're a Node.js application, and which port are we listening on. You noticed I went to localhost 3000 a moment ago because my app's going to be listening on port 3000. So let me just close a couple of these windows and collapse this and explain what that's done. That's added these three files here, these Docker Compose files and the Docker file. I'm not going to be using the Docker file today. I'm not going to be using the Docker Compose files, the YAML the files here, but I am going to be looking at the Docker file. For those of you who are new to Docker, have never seen a Docker file before, I'm going to quickly step through what some of this is doing. If I just break it up a little bit like this, it makes it a little bit easier. It's worth mentioning I don't need to edit this file. It would work absolutely as is. I'm just coming in here as a part of the demonstration to kind of expose what's going on and explain a little bit. So we have this top line as kind of the critical part, from node latest. What does that mean? Well, nearly all Docker images are based on a source image. They're kind of layered on top of it. So in this case, we're going to use the Node image, which is provided by the Node Foundation and is hosted over on Docker Hub publicly for anybody to use. The latest part means bring down the latest version. So our application is going to be layered on top of the official Node.js Docker image that's published. This just provides some metadata down there. And this part's the kind of key build steps. So if you noticed earlier, I ran npm install. So this is what this is going to be doing. It's actually doing it into a temporary directory and then copying it back in. So it's a little bit more convoluted, but fundamentally it's running npm install for us. Then we have expose 3000. This just tells the Docker engine, the system running this, which ports my application is going to be listening on. And then finally, the Docker image is going to start up by running npm start, just like I did a moment ago inside my Visual Studio Code environment. So that's kind of ready to go in a way. One thing I need to do is just, before I move on to the next stage, which is to create a Git repository to store my code in. And I can do all of that within Visual Studio Code as well. So I can come across to the source code tab, initialize a repository. It's now telling me I've got a load of changes now I need to be able to check in. So I can add these changes, stage them, and I can say init my new repository, just an initial commit message, and check that in. So we're in quite a good place. We've got our application up and ready. We've got it stored in a local Git repository, and we can move on to the next step. So for this next part, we're going to move out of the kind of code environment a little bit and move across to doing a little bit more in the browser. And what we're going to look at first is Visual Studio Team Services. So this is a hosted software as a service solution for all of your teams to work on the kind of software delivery. It was Microsoft Team Foundation Server, that's still available as an on-premise solution, and the hosted software as a service version is Visual Studio Team Services. This can do a lot of different things. It's a very comprehensive solution, but you can kind of break it down into 6 key areas. The kind of work aspect, where you can manage your agile and scrum processes, track your user stories, your bugs, your tasks, what everybody's doing, use Kanban boards and report on that and provide dashboards around what everybody's doing. Obviously, it's the source control aspect of it. We provide unlimited private Git repositories inside Visual Studio Team Services. You can also use the kind of native Team Foundation version control and bring in GitHub repositories as well if you want to do that. Testing aspect is quite rich. You can do load testing, continuous testing, exploratory manual tests in there and define all of your test plans. Package management to host your application artifacts, various package management formats. And the 2 aspects I'm going to really focus on today, the build and CI and release. So these are both automated pipelines that can do both continuous integration and continuous deployment. Very, very flexible set of capabilities and tasks that you can build into an automated sequence and basically orchestrate both your build and your release. It's probably worth mentioning that the build process isn't just for Microsoft or .NET applications. You can build just about any language using Visual Studio Team Services, and the same with the release and deployment, although today we're going to focus on releasing into Azure. So this looks, I'm going to jump across into Visual Studio Team Services. This is my account here. And what I'm going to do initially, move away from this slightly silly dashboard, is create a new project. So that was the demo project I was just looking at. I can tell Visual Studio Team Services to create a new project. So let's call this Node Demo DevOps. The name of the project is not that important. And I'm just going to create this. And this is also where I can specify the version control system I'm going to use. And if we're going to be using the work item area, which I'm not, if you're going to use Agile or Scrum or what methodology you're using for your development process. So in a second, this will have created me a new project. Ta-da. And what it's telling me basically initially is you've got no code in here. We need to put some source code into my project to really do anything meaningful. So down here, it gives us some clues to do that through Git to be able to push a Git repository into Visual Studio Team Services. So I can do that quite easily. Come back to my command prompt here and add the Visual Studio project as a remote, and then push it up. Should only take a second. Great. Come back here and refresh this view. There we go. So I've now got my local repository linked up with the remote repository over in Visual Studio Team Services. The next thing we need to do is set up a build. So we can do that from here, come across and create a new build. We need to do some prereqs before we can do that. And the main one is to create an Azure container registry to store our images that we're going to build. So our build process is going to need that before we make a start. So to do that, I'm going to do a couple of things. I'm going to use the Azure CLI. There's a new version of that. It came out fairly recently, Python-based one. This is cross-platform. It's Windows, Linux, OS X compatible. It's not based on PowerShell or anything like that. It's quite a powerful, pluggable CLI. We're going to bake into a lot of different aspects, both in the Azure portal and a lot of the tooling is going to use this CLI. I'm also going to use Bash for Windows. So this is a subsystem now inside Windows 10, which allows me to drop out into a Bash session inside Ubuntu 16. There's no virtual machines needed, no Hyper-V. Makes it really, really easy to do kind of cross-platform stuff. So I lied a little bit. I am going to drop back into my my code window here. And what I'm going to do is start up Bash. So I'm now in a Bash environment, a Linux environment, and it's sometimes a little bit misleading. But yeah, this is definitely not Windows anymore. I'm definitely in a, even though it says PowerShell here, I've got sort of a Bash session inside that. So there's a couple of commands I need to run. So I'm going to interface with Azure directly to create an Azure Container Registry. So what is an Azure Container Registry? Fundamentally, it's a hosted version of the Docker V2 registry, but provided to you as a privately and as a service. So I haven't got to create a virtual machine or spin up a Docker container to host my registry. It's provided natively to me through the platform, and all of that's managed by the Azure management layer behind the scenes. It's natively integrated in Active Directory if we want to put role-based access on this. And because it's a standard Docker registry, you can use all of our normal tooling and integrate that with things like Jenkins, or in this case, Visual Studio Team Services for continuous integration. So a couple of commands I need to create this are tucked away here. So first thing I need to do is create a resource group using this command prompt. So AZ is the new CLI. You can see that scrolling up the screen here. This is the CLI I'm going to use. So I'm going to use a couple of subcommands, ACR to manage your container registry and group to create a resource group. So this first command creates a resource group. I'm going to call it temp.demo. No reason for that name, it's just that I clear up all of my resources that start with temp at the end of every week. So that's just creating a resource group, just a logical container to store my resources in. And then I need to create the registry itself. And that's a slightly longer command, so I'm definitely going to copy and paste that. And I need to give this a couple of parameters. I need to give my registry a name. So new demo reg will probably be good. This has to be globally unique. So it creates a DNS entry, an endpoint, a public endpoint for my Docker registry. So if I pick a name that somebody else has got, I'll get an error and a clash. I'm pretty sure no one's taken that name before. And I give it my resource group name. So this is going to go away and build that. It should only take about a minute or so. Long running operations, probably overstating it. But while we're waiting, rather than staring at this screen, I am going to quickly jump across to the Azure portal. I could have stayed at the command prompt. There's no reason to come into the portal at all. Everything I'm doing could have been managed purely from the command line access. I'm just coming across here to demonstrate what's going on behind the scenes and to kind of just evidence what's happening. So that's created a resource group. So I can come across into all resource groups here. I have a lot of different resource groups set up in my account. but temp.demo is the one that I just built. I can come across into that particular resource group and we can see what's going on. The deployment's just finished. So it's built this container registry, it's built some storage for it. So my images will be held in our object storage in a storage account. And I can come into that registry and I can manage it, control it, and do various actions from here. I can also see if there are any images in it. There shouldn't be because it's only just been created. But when we start building stuff, this should be populated with the Docker images that we're creating. Okay, with that, we're probably in a good position to come back to Visual Studio and start kicking off our build definition. So these are templates that's prompting me for here. These are templates to get you started with the continuous integration side of Visual Studio Team Services. There's lots of different templates in here. You can see, things like Ant, Gradle, Maven, Android. It's very much a very open system. It's not just about building Microsoft projects. We've got integrations with Jenkins here, Java. So yeah, don't just think Visual Studio Team Services is just for Microsoft stuff. So down here, we've actually got a template we can use, which is to build an image. So we can use that as the basis of what we're doing. Let's give this a slightly nicer name than that. Build my app Docker image. That will probably do as a name. It's going to pull our source code down from this project, but we could pull our source down from GitHub if we wanted to, or another remote repository. On this build step, this is where we're going to obviously carry out the build action, basically similar to running Docker build at the command prompt. And we're going to plug it into this Azure container registry that we just created. To do that, Visual Studio Team Services needs to know about my Azure subscription. And I can do that by clicking this Authorize button, which is going to link up VSTS with Azure to authorize it on my behalf to carry out actions inside my Azure subscription. So listing stuff, editing resources, and just generally be an API interface linkage between VSTS and Azure for resource management. So that's done that. So that means it should be able to query Azure and list all my Azure container registries. So new demo reg was the one I just created. So that's the one I want to select. What I want to do, I want to build an image, leave all this alone. The other thing I want to change is the repository name. So I'm going to call this my app, and I'm going to tag it with the latest tag as well. So what does this mean here? Just to clarify a little bit. My app is obviously the name of my image, colon, and then the kind of version. So we're going to tag each build of my image with the version, which is then from a variable, which happens to be the build ID, the build that we run. We have push an image step. So once we've built it, we want to push it into that registry. So same as before, select our Azure connection, select our registry, push an image is our action. Give it this name, include the latest tag. There's one other thing we need to add in here, and this is just to allow Visual Studio Team Services to link our build and our release process. The release process is expecting some artifacts to come out of our build, and there aren't any in this case because we're pushing it into a Docker registry. No physical file artifacts get created. So I'm going to create a dummy one. Let's just call it dummy because it's not really used by the process. It's to trigger the continuous deployment later on. Right, a couple other things to change while we're here. We're going to turn on continuous integration. So this means when my code's deployed and pushed into the repository, it's going to trigger this build process. And I'm also going to tell it to run on these Linux agents. So with the VSTS subscription, you get everything I'm showing you here. Behind the scenes, we provide build agents, a pool of agents for you to be able to use to run your builds. So they're hosted on our behalf by Microsoft, and I'm going to use this pool of agents called the Linux preview agents because these Docker commands need to run on a Linux host. So that's probably all ready to go. We can save this. We've got a build ready, or a build process ready, let's say, to build my my app Docker image. To trigger that, I could simply create a build, run a build here, but I'm going to do it through a bit of continuous integration. So I'm going to come back to my application here. Let's make a tiny change to our application. I'm just going to put demo trigger in here. Save that. So this has then got some changes in our repository that we can then commit up. Let's call this trigger CI. It's just a dummy change really, just for demonstration purposes. This isn't any real application code change. But when we push this, and push that back up to VSTS, what we should see happen is the build process should kick off automatically. There we go. So it's triggered this. The build's in process, and we can come into that and take a look at what's going on. So it's connected to that hosted agent, the Linux agent I mentioned earlier, and it's pulling down both my source code and running through the Docker build step to carry on through this. So this will probably take about 2 minutes. Let's come back in a second and see when that's finished. The build process has gone through. Okay, great. So our build's completed, ran through cleanly first time, which is always a nice bonus when you're a developer. It ran for about just under 2 minutes, so I just did a quick cut there basically to the completed process. But that's run through. So we've got the full logs of the build process here. Everything is done, and yeah, we've got to now create a completed build in our repository. So the next step really is to define our release process. We do that from the same area inside VSTS. We've got builds and releases. They're kind of treated as separate processes. So I can come across to the release stage here. And we're going to quickly create a definition. We're not going to use this definition because I'm going to import the definition from one I've already created, which we can store as a template file. But similar to the build process, there's various templates in here, all sorts of things. This one's quite new. I just noticed the other day, which lets us deploy to a Kubernetes cluster. And we're adding to this library on an almost weekly basis. But we're actually going to start with an empty one. And what I'm going to do is quickly save this, because I'm not going to use this definition. What I'm going to pick is this option up here, which is import release definition. And what I should have in my file system here, and it's in the Git repository as well, in the extras folder, is this release definition.json. If I open that, it's going to create me a working definition to deploy this Node application. So we can give this a slightly nicer name. So let's take the copy off the end, and then I can explain what's going on here. So in this release definition, we've defined 3 different environments: dev, test, and staging. And then we have tasks in here in each of those different stages. So dev, test, and staging, I actually have the same tasks in each one. And in each task, we're carrying out a deployment into Azure. We're going to quickly restart the app service, and I'll explain what the app service is in a moment. And then we do some very, very minimal testing, which is just basically, is the deployed site up and available? If that's all passed, then the next stage gets moved on to, deploys into test, and then through to staging, and so on and so forth. So you can define in here, for example, the deployment conditions of when that particular environment is deployed or isn't. So what's going on in here? This Azure deployment is using a template file, using something called Azure Resource Manager to instantiate our resources. So let's talk about this very quickly. Azure Resource Manager. This is kind of the central DNA really that lives inside Azure. Every resource that exists and you can create it inside Azure lives inside this model, this resource manager model, which lets you, defines a set of resource providers of different types, but then provides a common API surface against all of those resources. So the way we can work with resources in Azure is then very similar, or in fact identical, no matter what the resource type is, whether it's a virtual machine, some storage, some SQL, a website. All of those different types of resource are managed the same way through what's called Azure Resource Manager, or ARM. So this then lets us do a number of different things. We can orchestrate the build process across these different resources. We can manage them through different command line tools. So that AZ command I ran earlier is using this ARM API properties and management layer. There's different tooling and service software development kits to let you to talk to Azure. And of course, we obviously got tooling for different systems here. We provide a large library of what are called templates. I'll explain what they are in a second over in GitHub. And we've got tooling for Visual Studio Code, and other code editors. So I mentioned templates. A template is a JSON document that describes the desired state of a particular set of resources. This lets us do basically idempotent deployments, so they can be deployed on top of the existing resources without destroying what's there, and the resource management engine inside Azure makes intelligent decisions about whether this resource needs to be created, deleted, or modified based on the current state and what the desired state is over in our templates. So that very much lends itself to the approach of infrastructure as code, which is exactly what Azure Resource Manager is all about. So in our template deployment here, we're pointing at this JSON file, which is one of these templates, and we can quickly take a look at that. We're just going to open it up. This is actually stored over in a GitHub repository, a different GitHub repository, one where I store all of my ARM templates. I'm really going to quick over this, but we have parameters, which are kind of inputs, different values we want to pass into the template to be able to change what it does. We have some built-in variables, which are used internally by the template. But the key thing is these resources. So we have different resources in here. We have a resource plan to store a particular resource here, kind of a web server farm. And then we just deploy a website into that farm, and we have various parameters that we pass into it. So this all looks really complicated, but there are getting started guides and the GitHub repository full of these templates to help you walk through that. So we're going to deploy that template. We have a lot of input parameters in here, and we're actually passing into those input parameters that you just saw in the template variables that are stored in VSTS. So we're going to pass all of these variables into our template. And we're going to build an Azure web app to be able to, through that template, through infrastructure as code. And then we're going to restart that app service, or what it's called, a web app. So what are they? The main resource we're standing up is an Azure web app. These have been around a while. These are kind of our main platform service, main kind of platform as a service capability in Azure for hosting applications. Been around a long while. They provide a lot of different capabilities. So over on the right-hand side here is kind of some of the key ones. Ability to auto-scale your applications based on rules and demand and workload. Provide deployment slots, which allows us to do continuous deployment into these applications and lets us do swapping, A/B testing, testing in production, and lots of nice stuff like that. Lots of enterprise features, or things, management features that you'd expect: backup, integration with SSL and your own domain names. Lots of monitoring and diagnostics, and integration with Azure AD for identity and access management. And what we've done is we've had this capability for a good while. It's been based on IIS. We're now bringing out a Linux version, which is based on Docker containers. So this then sort of opens up a lot more kind of open source capabilities, but with all of that nice management and kind of platform as a service wrap around it. So we can deploy Node and .NET Core and Ruby and PHP and Java applications, which are running inside containers. We provide a range of different containers for you, so you can just borrow them and get started quite quickly. Or you can bring your own Docker image, which is what we're doing today, and ask the app service to instantiate a version of your own Docker image. So that's what we're doing with this Azure web app that we're going to build and deploy our code into. So I need to make a couple of tweaks here. I need to tell this where to run, and I need to tell it about my Azure subscription. Apologies for all the clicking here. I just need, this is the sort of thing that couldn't be stored inside a template when I saved it. So, and it makes the template reusable, so you can use that the JSON file I used to create this and reuse it yourself with your own accounts. Okay, great. A couple other things we need to change. It's still in red up here, this variable section. So this is where we pass in the variables into that template. So I need to know something about the registry and its password. So if you remember some time ago, I was in the Docker in the Microsoft Azure portal, and I had my container registry I was looking at here. I can get information about it from this access keys blade. So I can get the registry name, which is what we need. Paste that in. And I can get the secure password here. And then that's held encrypted inside Visual Studio Team Services. Great, we're good to go. We've now got a new release definition and these 3 different environments. I'm just going to quickly delete this one we no longer need. And if I come across to this overview here, we can see this release and the different environments here. It's quite a nice way of visualizing it, and we can click here and create a new release. So that's created release 1 for us. We can come into that release and see what's happening. So we can see it's in progress in the dev environment, and then it's going to move into test and staging, assuming that the dev environment is deployed cleanly. Just like the build process, we can come across to logs here. We can see which agent this is running on. So this is one of these hosted agents. And in a moment, once that agent gets allocated our work, we'll see the logs appear and the deployment start to happen. So that's just kicking in right now. So it's moving on to the task of starting the Azure deployment. So that's now deploying that template over into Azure. What we can do is quickly come back to the Azure portal, and I'm going to go into this resource group view. I'm going to jump back out to this group view, and we can see OSS demo node app release, which is the group name we're creating for this particular infrastructure as code being pushed out. And we can see it's actually running through that deployment right now. So it's building as an app service plan, which is the chunk of resources that our web app's going to sit in, a kind of reserved piece of compute and storage, enabled to host our application. And then in a few moments, it will have created the web application itself and deployed that in there. So while we're waiting for that, I'm just going to pause for 1 second. Okay, great. It's now deployed the web application in there, as well as my app service plan. I actually only took a few more seconds. And what that's done is within this web application, we're able to go in through the portal and understand what's happening. So this is quite a rich management interface. A lot of things we can do in here. We can configure that scaling I talked about, custom domains, application settings, the Docker properties itself. We can actually set up our own continuous delivery. This is something that we've added in quite recently to go through, very similar to what I've set up by hand. This is a kind of guided way to do that. But the real thing we're coming here for is this link here, which is the URL of the web application itself. And what it will have done is deployed our Docker container, standing up our Node application. So if you remember right at the start of the demo, this is what it looked like. But then this is now running in Azure. So the URL is azurewebsites.net, running in the development environment. So it's running in a Linux host. This gobbledygook means it's running in a container, and yeah, it's detected that we're running in a Linux container. And our code that I updated a moment ago with this extra comment at the bottom has been pulled across as well. So that's the dev environment stood up. If we come back to the release process here, we can see it's already started to deploy the test because it passed, the dev environment passed cleanly, the deployment was clean, so the site was up. So that was good enough for deployment to proceed into the test environment. So that's been deployed into the same resource group in Azure. that's going to deploy a second site in there hosting our test version of our code. There we go. Patience. So now we've got a test version of it. It's going to deploy our container into that instance. Notice we don't need a second app service plan. That's one plan what you can use to host multiple sites. And this test instance of it will have a different URL. This will probably take a couple of seconds to deploy because it's got to start the container up the first time. There we go. Let's just deploy that. So we now got our test environment. And our release process is going to trundle through and start deploying the staging environment after that. So there we go. We've got a full end-to-end continuous integration, continuous deployment process. We can wait for this staging environment to be deployed, but it's going to deploy a very, very similar thing to the dev and test stages. We have our application changes being pushed straight through into Azure. It's being run inside a Docker container, run inside a Linux web application. We haven't had to create any virtual machines. I could have done all of this from the command line, but I did choose to go into the portal for some of it. So I hope this has been useful. As I mentioned at the start of the demo, you can try this yourself. That's the URL, aks/DevOps lab. If you want to have any questions, if you want to get in hold of me, if you want to try this out, I'd love to hear from you. That's my Twitter handle, Ben Code Geek. And yeah, I hope you've enjoyed it. Thank you.